sub 1 here be? A sub 1 is going to be just your number 2, meaning that's the first term in the sequence, okay? What is going to be your common difference? Meaning, how am I going from one term to the next? Okay, what would be that rule? Okay, and hopefully you picked it up. We're just adding 6 to everything. Now, instead of writing out common difference the entire way through, we're going to denote that by just using a little d. Okay, and we're going to use that for our difference. Now, to actually answer the question, determine whether or not the sequence is arithmetic, I should be adding 6 to every term. If there was a term where I all of a sudden added 4, you know that it's not arithmetic. Okay, so to go from 2 to 8, is this an add 6? Yes. 8 to 14? Yes. And here it's plus 6 and so on. Okay, so the next term in the sequence, if I was to ask you that, would be 32. Okay, so I'll give you another one. Again, just a simple yes or no. Is the following sequence arithmetic? If I said to you 7, 9, 11, 14, 16, ... Okay. So what would you think? Do you think that this is arithmetic? Okay, well the answer is no. Okay, it looks like it is though, because for me to go from 7 to 9, I'm adding 2, right? And to go from 9 to 11, I'm adding 2. Okay, but look at what happens here. For me to go from 11 to 14, that's going to require an add of 3. Okay, right there spoils the fun of it being an arithmetic sequence. Okay, so the answer is no. It's not an arithmetic sequence. Okay, now, again, I'm saving this for the end. However, I am going to kind of relate this to a theme park ride, a roller coaster. I think we all, or at least I love them anyways. I just started loving them recently, to be honest with you. But at the very beginning of the lesson, I gave you this diagram here and told you how this sequence here, having a common difference of 2, created a linear equation. Created a linear line, I should say. All right. If I am going up, let's say I start here, and I'm going up 2, and I go over up 1. Okay, and I go up 2 again, over 1, up 2, over 1. Do you see how I'm staying consistent here? Same thing with the common difference, it's staying consistent. Plus 6, plus 6, plus 6. Well, if you think of it as a roller coaster, and you have that dreaded incline where you start going up, you notice how it's all consistent. You're staying on the same track. So it means, again, maybe up 2 over 1, up 2 over 1, up 2 over 1, and so forth. But what if you had all of a sudden this? You're on the right track. You're going up 2 over 1, up 2 over 1, and next thing you know, something changes. Okay, and what's going to happen? Unfortunately, your roller coaster is going to fall off of the track. All right? The idea here is we want to stay consistent on the line. We want to say that we want to make sure that our difference, our common difference, is consistent the entire way through. So again, up 2 over 1, up 2 over 1. Does it have to be up 2 over 1? No. But maybe up 3 over 1? Doesn't matter. The increase needs to be the same the whole way through. All right? So, what if I gave you this? 91, 83, whoops, 75, ... And I want the next 4 terms in the sequence. Okay? So first of all, what is our starting? What's our A sub 1? Just to make sure that you understand this, it's 91. A sub 1 meaning, again, the first term in the sequence. D meaning our common difference. What is the common difference that you see here? How am I going from 91 to 83? Okay, and the answer is we're not actually adding anything this time, we're taking away, right? And that's okay. The common difference can be negative. So in this case, I believe we are subtracting 8 from each term. Okay, so again, minus 8, minus 8. And if I want the next term, all I have to do now is just take another minus 8 and keep going. Okay, so this is A1, A2, A3. So what I'm after then is A sub 4, A sub 5, A sub 6, and A sub 7. and once more the fourth term in the sequence. That's what that signifies. Fifth term in the sequence, sixth term in the sequence, seventh term in the sequence. Okay, so take a moment, you can pause the video and see if you get these correct. Okay, so the answers here, the fourth term in the sequence should have been 67, then 59, then 51, and then 43. Okay, and as you can see here, this makes this what we call arithmetic because the common difference is constant within each term. Subtracting 8, subtracting 8, subtracting 8, subtracting 8. Okay? Okay, now, you know, with the previous examples that we've just done, I've given you a sequence and I've just asked you for the next 4 terms. Well, as fun as that is, it's not really all that interesting. You know, what if I was to ask you, okay, based off of the common difference here, what if I wanted the 64th term in the sequence or the 83rd term in the sequence? Okay, so there is a specific formula for a given term in a sequence, meaning if I wanted that 83rd term in a sequence, this is the formula that I would use. Okay, now let me kind of dissect this a little bit here. This a sub n, remember this is the term that you want. So this is the term desired, so to speak. Okay. What did a sub 1 stand for again? Right, your starting term in the sequence. Okay. N, of course, is still the term desired. Same thing. And then what did D stand for? That was our common difference. So as long as you know the first term and the difference, all you would have to do is just simply plug in and you'd get the value that you're after, that you're looking for. Okay? So, for example, if I give you the following sequence of 3, 6, 9, 12, ... Okay? I don't want the next 4 terms. I want the 30th term. Okay? Now, if you wanted to, you could count, you know, whatever the common difference was all the way until you get to the 30th term. But believe me, this is really simple to use. Okay? So, essentially, if I'm applying this formula, it's going to be the following. A, 30, because 30 isn't that the term that we're looking at for? That's the desired number, right? Okay, a sub 1 is going to go next. What was our starting term here? It's 3 plus n minus 1. Now, n is the term that I'm after. N here is 30. Okay? Subtract 1. That's just a given. That's part of the formula. And then our D, our common difference. So what is the common difference between 3, 6, 9, 12, so forth? Okay, we're actually adding 3, so times by 3. Okay, so all I have to do now is just clean this up a little bit, and I get 3 plus 29 times 3. Okay, and that equals, okay, so the answer to this would be 90. Okay, so if you were to continue this string of numbers, the sequence all the way through until you got to the 30th term, the answer would be 90. All right, let's try another one. All right, if I said to you that we had 2, 9, 16, 21, ... Okay, and I said to you I was interested in the 15th term. Okay, so remember, technically the only things you really need here in the formula, you need the common difference.